hopefully we'll have a little discussion going back and forth. After each talk, we'll encourage, during the talks, we'll encourage people to use the chat to chime in. Everything's being recorded here, so don't say anything you wouldn't want everyone to know. I'll have a quick sort of summary. These are the slides that I posted there before. These are the speakers. And just Dave, I think, is probably best known for the work he did in the past on Jeopardy. But I think he'll probably want to talk more about the future than the past. And that I think he's thinking we're not being ambitious enough or rigorous enough. And that maybe something like Squad is, or Q&A of the Jeopardy kind, doesn't really count as comprehension. And I think he'd like to push us to something that would count. And the softball question I have is that I think much of the audience is probably thinking right now that things like BERT are doing really well. And I'd like to know if Dave thinks that BERT's not the solution. I'd love to know why. And for Ido, I think he's going to talk about moving out of our comfort zone. And, you know, again, in our comfort zone, we've had a lot of successes, but I think he's also kind of like Dave, thinking that we shouldn't be that happy with what we've done because we can do better. Alëna is going to be talking about, she has an amazing number of details about, this is from Google, and with a bunch of people from Google. And it's about what you would need to do to really collect data, to really do a good job measuring how we're doing in the speech area. And I won't steal too much of her thunder, but she's really thought, or they've really thought deeply about this. I might also say that I get to look at, I get data from YouTube about how all these videos are doing. And Dave's video is doing very well. It's in third place. John McCool's is in first place. And this one is in second place, which is pretty impressive. At least that's last I looked. Context is obviously important, and there's, I think, at least two different ways of thinking about context that will be brought out in this talk. One of them is a sort of systems view, which I hope that Greg will sort of chime in on. The question is, how can I compare performance using similar amounts of resources? And the other view is more like a web search view, which is the answers to questions depend on time. I think they also depend on who the audience is. Personalization is kind of extreme. They also depend on location and many other variables. And I really like the idea of trying to encourage more interdisciplinary collaboration. So I would love to see us reach out to other fields like systems and web search. We have people here in systems. I don't know if we have web search here, but that's certainly a related field. And Greg is going to tell us about ML-Perf and ML Commons and what, I don't even know exactly what the terms refer to, but I think he's going to tell us. And basically, I think this is a way to make our benchmarking look a lot like the kind of benchmarking that went on in systems. And we have a really wonderful talk from John Massey about SPEC, which is the benchmarking that was used for pretty much all the computers we use for a few decades. Sam is going to tell us that evaluation's broken, but we can fix it. And he's got a lot to be said here. And I think this is kind of reaching out towards experimental psychology, the way we used to think about validity and reliability and such questions in the 1950s. And again, I see opportunities for more interdisciplinary work. We have some talks by some psychologists, at least in another session. So with that, let's move on and hear from the speakers now. So Greg, do you want to start?
Sure, I'm happy to, Ken.
All right, so I'm going to stop sharing.
Okay, I'm going to attempt to share and hopefully it will work.
Okay. If it doesn't work, I can share for you.
Can everyone see this?
Yeah, I see your slides.
Great, and let's see if I can move into presenter mode. Can you still see this?
Yes.
Okay, so as Ken mentioned, I'm going to tell you a little bit about MLPerf. And, the hope here really is that, there are opportunities for interdisciplinary collaboration. That this is a benchmark that we built started about 3 years ago. And as Ken mentioned, this is heavily influenced by the SPEC benchmark. And John Massey was one of the founders of the SPEC benchmark, gave another talk. I'd encourage people to take a look at that. But there's this history in systems, benchmarking in systems, to really align the field around single metrics. So SPEC, which MLPerf is heavily based on, lasted for, was created in around 1988. And so it's been in use for over 30 years. It's still going strong. MLPerf actually isn't intended to be a replacement for SPEC. It's maybe an expansion of the field to cover a new area that wasn't covered by SPEC. But there's this history in systems to have these benchmarks like SPEC that the entire industry participates in and that last for a long time. And so this talk is sharing some of the lessons that we learned when we built MLPerf. And so let me tell you a little bit about that. So the talk really has two pieces in it. It's a little bit of background on what is MLPerf. So again, not assuming people in, not in systems are probably not taking a deep look at this. So I'm going to give a little bit of background on what is MLPerf. And there are a lot of lessons that were learned while building things like SPEC and like MLPerf. And so the second part of the talk tries to distill some of these lessons down and at least speculate how they could be applied to benchmarking in NLP. So the most important thing, I think, the most important defining characteristic of what is MLPerf is that it's intended to measure machine learning system performance. And it does this with a benchmark suite. It follows in the history of, from Mark Lieberman's talk, the DARPA Common Task methodology. And probably the most defining characteristic about these benchmarks and systems is that they have broad industry and academic support. So the companies that build the fastest computers in the world, if they're building a CPU, they submit to SPEC, and if they're building an AI chip or a machine learning system, they'll submit to MLPerf. So we actually have this pretty large community of most of the major industrial players who will submit to these benchmarks. And there's also a larger community behind them. So there's engagement with academic groups and smaller companies and startups and more focus on innovation. And the entire community that participates in these benchmarks, even MLPerf, which is relatively new, it's only 3 years old, is about 1,000 members. So these are pretty large community efforts. And I think that's actually the most important piece of this. If you take nothing else away from this talk, the idea is that if you align the entire industry behind a single metric, you could make a lot of progress. And the example that we have from SPEC that many of us are inspired by is the progress we've made in computers. Like the speed improvements in computers that we've seen over the last 30 years have mainly been driven by having clear metrics and alignment across the industry. So the rest of the talk has, and I'm not going to go into, sorry, I need to get all the way to the end because I need to finish in 8 minutes. So there are these 5 lessons that the talk goes into more detail on. So we saw the first one around thinking long-term. We could make steady progress over a long period of time. It compounds, it adds up to a lot. So just like the speed improvements in personal computers or in the smartphones and personal computers, if you have a single metric that persists for a long time, then it can add up to a very large amount of progress over time. The second one I actually think is probably the most relevant one for this community. And so I just want to really highlight this one. We learned this in SPEC. So I encourage you to go watch John Massey's talk about SPEC. And we also learned this in MLPerf. Industry knows how to build benchmarks because there are products that are being released that are being, like in David's talk, I think he's going to tell us about it's important to think about people, how people fit in. When industry is building products and releasing products, they're being used by customers. And so they spend a lot of effort to try and understand their customers. And the thing that we've realized when we talk to real product teams is that they usually have, like, in order to build those products, they have clear ways of measuring those products. And moving from individual teams to the whole community and a single metric or a single benchmark is about going and gathering all of those insights from those product teams and then stitching them together. And that's kind of what we've attempted to do in MLPerf. And that was also done in spec. So there's three other ones on here. I don't want to take too much time, Ken. But yeah, hopefully you're, if you've never heard of MLPerf before, this gives you a little idea of what it is and some of the lessons that we've learned along the way. And I really do, I do think some of these are going to be applicable across fields. So I'll stop there.
So I think the purpose of these short talks is to be a teaser to get people to go watch the videos. So I have a question that's for both you and Eunsol. And Eunsol will probably be giving a talk a little later, which is you both bring up some really good opportunities for interdisciplinary collaboration. And I wonder if you could say a little bit about the collaborations that you are involved in now, and maybe what kind of collaborations you'd like to be involved in. So I gather this MLPerf involves collaborations with all sorts of people.
Yes, absolutely. So I think probably the most important piece is when we're building MLPerf, there were actually many individual benchmarks that were being developed independently. So there was an effort at Stanford that was called Fathom. There was an effort at Harvard, Stanford was called Daan. At Harvard was Fathom. Across the industry, most companies would have their own internal team that would be building an internal benchmark. And so I think the most important piece of collaboration is just talking across teams. So putting them all together into a single room. In spec, John Massey had the example of a bar in Campbell as being the neutral meeting ground to like get people together and to try and put them together. But I think that mechanism, just taking people who are already passionate about it, have been spending a lot of time on it, and then just putting them together into a room together, and letting them kind of combine the ideas, discuss the ideas, and merge them together is very effective. And so, I actually think very interesting things could come about mixing communities. So, in ML Commons, we have an NLP benchmarking subgroup, and we know that we have no idea what we're doing. And so I would love people from this community, who care about benchmarking to engage with us, and, maybe we could find a neutral meeting ground and see how we could synthesize, some of the ideas together. And I'm sure it would help us. I'm not sure actually if maybe some of the lessons for benchmarking from MLPerf could also be helpful.
Okay. So in previous sessions, what we've done is that people have asked questions in the chat or raised their hands, and maybe I won't belabor things. Maybe we should move on to the next talk and then see if questions come back here. Like maybe when Eunsol answers the same question, that'll get things going. Typically, questions start piling on. So why don't we go to the next talk? So if you can stop sharing. Gosh, my machine suddenly got very slow. Okay, so that'd be Dave Ferrucci. I guess you're up next, right?
Okay. Guys, can you hear me? Let me see if I share. So, yeah, I mean, I don't know that I need to take the full 8 minutes, but hello? Yeah, I've been, can you see my screen?
Yes, I see your screen
great.
Wonderfully.
Yeah, so, you started kind of with the softball questions, broad enough. I mean, I don't think any of what's out there is enough, but of course it depends what your expectations are. I still haven't given up on the vision for AI where I can fluently talk to an intelligent thought partner that could read, understand, and communicate in our language. Not just provide answers, but provide justifications for those answers that explain where they're coming from and how they're being derived, and ultimately help us solve problems, make informed and responsible decisions. And I think when you set that expectation out there, I'm not sure anything quite measures up. And, I think, like, what are we even working on that problem? Maybe not. Maybe we all dream about it, but we aren't all actually working on it because it seems too hard. Maybe we're just not setting up the right benchmarks, or we're not committed enough, or it just seems too far out there. It doesn't meet our shorter term incentives. I'm being a little bit controversial, but I think at some level, if we're all honest with ourselves, we'll say, yeah, I don't know that we're really quite trying to achieve that yet. I think we're building a lot of technologies that speak to that and that can be, start to be put together to try to solve that solution. And we've come an enormously long way in the field. In the last couple of decades, it's been remarkable. But are we closer to that vision? I think that's an interesting and honest question to ask. I spend time thinking about, because I've been in this business, as many of you, for a long time, and I think about how the expectations have evolved and what we thought would work and how our expectations were dashed over the decades. And stepping back and thinking, language understanding is really hard. Why is it hard? And what do we even mean by it? Is it a moving target? And this is a definition for understanding that I like because it focuses on having an effect on the human. So it's like, what is required for humans to make effective decisions? So if a machine is understanding, is it ultimately helping me do better at my task? And I think it's an interesting definition because it puts the sort of human front and center in that definition. And also, if we step back and think about when we say, does somebody understand something? Are they consuming information and producing understanding? We as humans don't find this particularly easy to do. In fact, we spend an enormous amount of effort getting other people to understand what we're thinking and what we're saying. And in fact, it might be the process of communicating and trying to explain an understanding where the understanding is actually refined, developed, and hardened. In almost every field we spend an enormous amount of time doing this. It's not simple. So at some level of what it means to generate an understanding, we certainly acknowledge that it's actually quite difficult. Enormous amounts of effort into it, and we still arguably don't do it well. For more inspiration around this, I love this cartoon. How do you not understand this? I explained it perfectly. Maybe your notion of perfect explanation should include that the person who's trying to understand it actually gets it, right? So this implies that understanding is even harder because when you think about that artifact that you're producing, if it's good, a human, you can explain it and get another human satisfied with it. In order to do that well, you might have to have models how that other human is formulating their understanding. That seems hard. The other thing is when we think about explaining, satisfying humans with regard to the quality of the explanation, we get very different types of explanations. So we see even a deeper problem, which is, here you have this question, are you headed for a recession? And you have, two answers. They're both yes, but very different explanations. One's giving essentially an inductive statistical explanation that says, things, when we had a recession last time, all the indicators lined up in a certain way, and they're lined up in a similar way now. So that should satisfy you. Another one gives a much more causal explanation of the system dynamics in markets about debt and demand and how they relate to each other. And you get a very different explanation. Which one is ultimately satisfying? Which one ultimately reflects an understanding? So, I mean, it's interesting how we build these systems. We build remarkable systems, but NLP for a minute, but even in image recognition has, just fallen prey to the recent advances in deep learning. Is really remarkable. But then you have these telling errors that say, well, wait a second, we have this adversarial example that's 98% sure that second person cat is a toaster. I mean, not to take anything away from image recognition, because for any given task, this is remarkable success. But, no human would make that mistake. So when we're talking about understanding, it's obviously building an understanding, if you can call it that. And maybe you can, but it's building understanding. It's not compatible with our understanding. And it's going to, it's not going to do well if our expectations is that you can really explain why you think that's a toaster. I think that to be fair to the systems that we build, that wasn't the goal. I mean, the goal was to do well with that classification task. The goal wasn't to produce a compatible model that humans would agree with how you derive the answer. That really wasn't the goal. The question is, should it be the goal? And we have similar examples, and you could watch my talk in the language recognition space. But I think we could all step out and be honest and say, if that's your goal, we're not there. That would be, achieving that goal would dramatically change how we interface with computers. It would dramatically change the knowledge economy, actually. It's an enormous goal. We took a little step and tried to kind of make this comparison more, I don't know, just a little bit more rigorous. And it's one thing to philosophize about it. It's another one to try to, roll up your sleeves and kind of make these proof points. So we had this paper in the ACL, and I think which led to this talk, but the idea was, can we define comprehension in a little bit more of a rigorous yet robust way? And we said, well, the thinking that went behind this was, if a student were to sit down and read a story and forget about the multiple choice test, if you came and said, look, I want you to really map out your understanding of this, you might ask them to kind of draw you a map about all the entities and how their positions, relative positions changed over time. We might draw you a timeline. What were all the events and how did they occur through time with respect to each other? What events caused what states of the various objects to change in the story over time? And for every agent, can you explain what was motivating them to take the action that they took? And if you could map all of that out for any given story, I might say, hey, you got a basic or at least ground representation of an understanding that I can appreciate and I can understand. And I still have to judge it, but at least you're sort of answering the questions that give me a floor of an understanding, if you will, about what happened. So we said, gee, can we test current systems against this view? We didn't do this with a lot, with a giant sample size. It was very expensive to do, but we kind of got at least did this concept proof where we actually had humans sit down, read these stories, and build out this record of understanding, meaning they just mapped everything out. The map, the timeline, the causal models, they did, basically did it all, even the most obvious stuff for every story. So, 5-sentence story would turn into like a 10-page document almost. This was this record of understanding that we would produce. And then in order to test existing systems, unfortunately, they work in multiple choice. Our view was multiple choice has lots of problems, but, we'll compromise. And we took a few of these and we turned them into multiple choice questions that had the entire coverage of the record of understanding. So we took the race stories and we did that, for just a couple of stories, we got 200 questions. And we did some variations, paraphrasing as well, to get some variations on the way we turned those records of understanding into multiple choice questions. And we took XLNet and ran it on this stuff. And it beat chance, but didn't do anywhere near as well as the humans who performed consistently on this. And then with the variant groups, it did even more poorly. Love to expand on this to continue to make the point that maybe we're not really, even in the simplest sense, not quite where we want to be. I think the goal should even be larger than that, but this is the type of experiment that we think helps us raise the bar. And this was still just kind of a weak test. We don't think it should be multiple choice. We could be even full text response, maybe even graphical responses, draw me a picture of your understanding, maybe interactive and explanatory dialogues to answer why. Ultimately, did the understanding improve the user's ability to make better decisions? Is sort of an interesting way to think about it. In any event, that's kind of the idea behind it. And I'm motivated. I've been in this for a long time, but I'm still motivated to reach for the bigger goals. So can we design benchmarks that kind of get us to achieve the more ambitious vision? Anyway, that's my pitch.
Well, great, thank you. So do we have any questions? Anybody want to raise their hand? Did I see a hand up, Sam? You actually raised a hand the old-fashioned way, but then you did it with the high tech too.
Yep. Yeah, so there's a bunch of cool stuff here. But for the record of understanding in particular, this is a question I think I've seen your take on a little bit, but I'd like to hear more. Which I think you gave this intuition that, like, all right, if we get this record of understanding, then that will look like convincing evidence the system understood us. And I feel like that template on its own doesn't sound like enough of a recipe for choosing what task to focus on. I think there's a lot of this around Winograd schemas, where there was this intuition that if we solve Winograd schemas, we'll believe systems work, and then didn't turn out to be true. Sort of how do we secure ourselves against this? How do we make sure that we're picking tasks where if we succeed, we can be pretty confident in the interpretation?
I think
before you answer that question, can you explain to the audience what the Winograd schema is and why it's relevant to this conversation? Or, because I'm just worried that we got some inside baseball here and people don't know what we're talking about. Or Sam, do you want to explain that?
Yes.
Sure. This was go for it.
No, please go ahead.
Sure. These were these sentences of the form, the trophy wouldn't fit in the suitcase because the trophy was too big, or because the suitcase was too big, where just figuring out the task of the model is to read this sentence, like the trophy wouldn't fit in the suitcase because it was too big, and decide what it was. Sorry, I think I'm saying this confusingly, but it's this ambiguous pronoun it. And depending on the structure of the sentence, it obviously implies it means one of the things.
The concept is sometimes in order to make those pronomial references correctly, you need some background knowledge that's out in the story or not in the sentence. Like you need
and that background knowledge was interpreted as understanding. And now where you're going back and forth is to say, that was a nice attempt, but it didn't seem to work. Is that what you were saying, Sam?
Yeah. I'm not sure whether this is kind of more the error beforehand or more the error afterwards, but the original proposal, and I think some of the media discussion of this back in 2010, 11, 12, this got a lot of attention, was that, all right, this is a good proxy for a Turing test. This is good. If we can do this really reliably, here's a few hundred examples that feel like a good proxy for this. We've got this class of common sense done. And I think we mostly solved that. And I think very justifiably is a lot of concern that these solutions, there's reason to be a little bit skeptical. I think people aren't taking it as seriously as they would have given the initial explanation. So I guess how do we?
So the thing is that there are machines that do well on this task, but don't seem to understand.
Yeah, or at least.
And so now
it is common not to take that as evidence now that we've actually observed the evidence.
Right. So your question to Dave is, how would we, if we could do what he was saying, how would we make a convincing argument that this is understanding, or what would we use it for, right?
Yeah.
Okay. I just want to make sure the audience understands where we're going before Dave answers it. Now, Dave, please answer it.
Yeah. Okay. So, I mean, my answer is going to be, shorter than the conversation about the question, but I don't I don't have the easy or short answer. I mean, I think the hope and expectation that I have is that we keep pursuing that. In other words, we keep raising the bar. I think one of the things that we struggled with, even when we were doing this, was acknowledging that really evaluating whether or not a system has a good understanding is a tough problem. And a lot of the things we focused on was, did it draw from some ability to use background knowledge and reasoning that was not apparent, was not explicit in the story? And I think that's where it has some similarity, at least what we did is some similarity with the Winograd scheme. Is I think that the robustness of the expectation of the system to just engage more and explain its answers and how it's deriving its answers was much more of a focus for us. We actually built a system that we thought produced good understanding. I could show you a demonstration of that. But again, it's still kind of where do you usually the line and when is it enough? And I think that's just a broader question. I mean, even if you look at how we establish shared understanding amongst humans, we're constantly probing, and in the talk I talk about this, we're constantly probing, constantly dialogue, constantly testing to see if in fact we have an alignment of the understanding, or that it's sufficient enough to take action on. So this is kind of the point earlier, is like, you can't really take the human and the interactivity ultimately out of that. But even beyond going that far, we can just continue to raise the bar, I think, for what we expect these systems to do along these lines. I'm just suggesting along these lines.
Yeah.
So I was thinking a little bit, like maybe I'd try to hear from John Massey about this. But what I was thinking is that it's many of the benchmarks we come up with, I think, are gameable. And I think some of the benchmarks that predated spec were gameable. That the marketing people would ask you to put in a special piece of code or hardware or something to do well on a benchmark. It feels a little bit like Volkswagen managing to do well on the clean diesel benchmark without actually having clean diesel. And what what we were saying with the Winograd thing is that it seems like it's possible to answer this question that we thought would be like the Turing test, but in fact you can answer the question without.
I think we're always surprised to find out how the patterns that are available that make things quote unquote gameable. It's always sort of interesting to discover that, but at the same time, is understanding gameable? I mean, it's a
no. I mean, but one of the challenges here is if we could come up with a good benchmark that wasn't gameable, then we could push the field in good directions.
Yeah.
Now, maybe the other thing you would say is we're on our honor. Use the honor system. Don't cheat.
I don't know. I don't know that. I think that the pressure's on the people designing the benchmarks to see if they really reflect what we want. It's hard, but I mean, I think that's the challenge that we have, and it's a good question. I mean, we built a system literally that builds a timeline and builds a map and builds a we literally did that.
So you have a solution and you did it honest, but what's to keep somebody else from doing it?
Well, I mean, we did a demonstration that shows what a more robust understanding might look like. How far does that scale is the tough question.
So John, do you have some experience from spec?
Yeah, I think there's two separate cases. There's cases where somebody absolutely games a benchmark. One of the classic ones was this Drystone benchmark I mentioned, which copies a 30-byte character string from one string to another, which is normally a half a dozen instructions per character, okay, because they're C strings, right? So somebody converted that into something by saying, well, we can align the strings on 32-byte boundaries, and we can use two 16-byte floating point instructions, loads and stores, and do it in 4 instructions, which has nothing to do with anything like any real program. All right, so that's outright cheating. The other case, though, is where a benchmark doesn't measure what you think it does, okay? right? Okay, and you only discover that later. Well, just 3 cases then. All right, so that happened to us in the very first round of spec. We all used the SPICE circuit simulator as a benchmark. The trouble is, most of us were using cases that were too short. HP had a longer one. We only learned, and we all knew it was heavy floating point. We all knew that, right? It turned out the one benchmark that we picked didn't. One input, all right? So we fixed that later. But so that's the thing where it just doesn't measure what you think it does. And the third case is where you have something that worked pretty well, but then the technology changes in a way that obviates the usefulness of the benchmark, not because somebody was cheating, but because it was too simple, and the newer techniques just sort of wiped it out as being representative anymore. And this happened with a little matrix multiplication routine where compilers learned to map matrices onto cache memories and just got a huge speed up. It was just too simple. It was a good technique. It was highly valuable, but nothing else in real life got that speed up. So there's different ways that, you know, benchmarks are bad. It isn't just that people are outright cheating. That tends to get detected fairly quickly.
Ken, can I share an ML-Perf perspective on this?
Please.
Yeah, David Kanter. I'm here to support Greg, and you know, we've been very interested in speech things. One of the things I'd say about benchmarks that I think is a little challenging, if I can fall back to my math background, I sort of think of benchmarking as being a real challenge in terms of finding generalizability, right? Because that's ultimately sort of what you want on one hand, right? Like the notion of understanding or good performance is a general one, right? But then you also have to come up with sort of representative use cases, because you aren't going to benchmark sort of everything under the sun. So if you think about it, to fall back on a calculus concept, somewhat akin to a Taylor series, right? We know that, you know, you can build a very accurate Taylor series across a neighborhood, right? But as you get further and further away, that approximation sort of falls off. And I think that's one of the ways in which sort of what John was talking about in terms of technological change, sort of rendering your approximations maybe not so valid, right? Number one. And then, you know, number two, you know, the best benchmark in general is exactly whatever you are doing, but then that totally fails the generalizability. Like if I look at folks who are doing deep learning for speech, I don't think there's a universal consensus on the right way to do it, right? Some folks will use some flavor of neural networks. Some folks will use different ones. It's going to depend on your data and all sorts of things. And that's a very broad space to try to approximate with a single benchmark or even a small handful of benchmarks. And then there's sort of for a benchmark to be useful, you have to get sort of buy-in from folks to run it, which means the overhead can't be too high, right? So if you were to look at the giant language models that a Google is running in production, that's not a good benchmark, because they're willing to spend a couple months of compute time for thousands and thousands of machines. No one's going to casually do that to help make a decision, right? That's the decision you are trying to aid and abet.
Yeah. So I think we need to move on to move Ido, but before we do, Sam Bowman put something interesting in the chat, and I think it is kind of central to this discussion. You can go read the chat, but the way I interpret it is that the way the neural nets are doing well on the Winograd system is kind of opaque. It's not like the kind of examples that John Massey brought up where you can actually look at what they did and then decide whether it's a legitimate or not legitimate solution. And what I worry about is that if a benchmark is gameable and the methods we're using to game it are so complicated that we have no idea what they're doing,
But isn't that?
Then,
But that's. I mean, kind of interrupting you, but so that's
please.
one of the main points what I was trying to make is that, I mean, do we have the requirement that we should be able to understand how a system's producing an answer or producing an interpretation? Is that part of what we want to include in the benchmark?
Yeah.
And I mean, that's a little bit hairy too, but it still has a clear position, a clear role to play.
Right. Well, so the question would be, how would I detect cheating? And if I don't include the requirement you're describing, it's probably harder to detect cheating.
Yeah, it's like you have to show your work, and I have to be able to understand your work. I mean, I think, anyway, I think there are some caveats with that, but I think the net is, my view anyway, is that absolutely should be included in the benchmark for anything.
Yeah. I suspect that that's a reasonable position, but I suspect that the majority of the community would take the other side. But at any rate, I'll let the ML-Perf people try to hash that one out, because they're the ones that have to come. They're going to have to come up with a way to appeal to their customers. Anyway, let's move on to Ido, because I'm terrible at timekeeping. Ido?